Hello, everybody. My name is Dr. Kale Stoley, although I think everybody in this class knows my name. Welcome to EGR 335, Digital Electronics and Microcontrollers. So, it's been a while. It's been 2 months since I've seen any of you. So, pardon me if I forgot how to be a teacher. It's been a long break. Anyways, I missed all of you, and I am happy to be back teaching in front of a camera instead of a classroom. So, this class is not too dissimilar from a lot of the classes that you've probably had me in. Everybody who's in this class has had me in EGR 325. Of course, that, for those of you who had me in EGR 325 last year, this class will be a little bit different than that because we're going to try to do a lot more hands-on stuff and a lot less send you home stuff. One of the nice things about this course is that we did manage to arrange it so that we can be entirely in person. This is not something where we're going to be doing a hybrid mode. This is going to be a lab-based course. And to me, that always makes me happy because I don't like hybrid classes very much. I much prefer in-person interactions. Now these videos, it doesn't bother me to make videos. It does take a lot of time to set up, unfortunately, and that's not something that I may enjoy doing. But on the same side, hold on, I'm getting up my app so that I can control this a little bit more seamlessly. On the same side, I am enjoying the fact that I get to work on hands-on projects with you. If, in my opinion, the best kind of education is one where you not only understand the concepts, the mathematics behind it, the science behind it, but you also understand how to use it and apply it to actual materials. So in this class, this is going to be done very much the same way. I have no intention of teaching this class entirely theoretically, where I throw a textbook at you and tell you figure it out. So with that note, why don't we go ahead and jump into the syllabus, because that's what we're covering today. Hopefully I haven't screwed up my video streaming because I've been messing around with it a lot. Hey, I haven't messed anything up yet. Let me check and make sure you can still hear me. Yay! All right. So this is the syllabus for EGR 335. This syllabus has been posted on Canvas. So you could have already read it. I have yet to update my office hours because I don't quite know when that's going to happen. I will figure that out as soon as I have one more class I need to arrange, or I guess meeting, and then I will figure out my office hours. When I do, I will update this syllabus. For now, if you want to talk to me about anything this week, please email me. I don't like doing open Zoom hours because I will not sit in front of a webcam for hours pretending that I'm okay, because I don't sit still well. So this, oh shoot, I forgot to update the required textbook. Nice. I forgot to update a lot of this stuff. Oh well. ignore this. We will be using a Raspberry Pi in class. Briefly, we are going to play with some other microcontrollers. I'm going to buy some ICs. We're gonna play with just building some circuits. It should be fun. But yeah. Basically, the overview of this course is that if you're taking this class, you have some interest in electrical circuits. You may be an electrical engineering emphasis in our engineering program, or you may just be taking this class because it was an engineering credit and I coerced you to do it. So that's another thing. There are a number of reasons to take this class, but what this course is going to cover is a lot of how to build digital circuits. In EGR 325, we covered a lot of analog circuits, power, voltage, current, that kind of a thing. We have moved away from that and we've moved toward digital communication. This week we're going to go back into what is the difference between digital and analog, what is a digital system, what does it mean. We'll cover that, so we'll get a little bit more groundwork built up so that we're ready for this class. Yes, we will also build some devices that involve programming microcontrollers. So the three main course objectives that I have for this class is I want to be able to understand and apply microcontrollers to electrical circuit designs. Now, one of the things that I want to do with this class is I actually do want to teach a lot more engineering design in this class, rather than here's one right solution, hand you a problem and say, here, you have to figure it out. That's a lot harder when you have to figure it out yourself. But at the same time, I feel like the educational quality of a design problem is substantially larger than the educational quality of just telling you to figure this out. I don't see this class as a very memorization heavy course. I'm not going to expect you to take tests, which I guess I'll get down into. Coursework for this class is going to consist of quizzes, reading assignments, design assignments, and one semester-long project. I'm going to briefly discuss the semester-long project today. I'm going to be giving you reading assignments every Monday, so I will assign you those assignments today. They will be due next Monday. That's pretty simple. You have to do your reading assignments on engineering paper. I put that in the syllabus. You have to write them, handwrite them. I do have engineering paper if you need it. It costs $6 for a pad. But you have to write it on engineering paper because when you scan it or when you take a picture of it, it needs to look professional. Simply doing it on line paper does not have the sort of professionalism that we require from this program. So you will be handing those in digitally. I will not be physically touching your assignments. I will only be handling your electronic documents. Okay. Design assignments are going to be assigned intermittently. I may assign one week. I may assign one that's due 2 weeks later. One of the things I want to do in this class, with this being more of a design-based class, is I actually do want to give you time to sit down and work on these circuits. We'll be covering a little bit of lecture material in person, Mondays, probably, and then Wednesdays and Fridays will be devoted to working on design problems, building, constructing, coming up with circuits, that sort of a thing. So that's kind of how I envision this. Quizzes are going to be posted on Canvas. I have discovered the beauty of auto-graded quizzes, because grading is one of the things I hate most about everything. So you will find that I'm doing everything within my power to not have to grade as much as possible. But quizzes will be provided on Canvas. I will post one today. No, I already posted one for next week. That is already on Canvas. I'm going to introduce the semester-long project. You will have a number of assignments that are due for that semester-long project. If you have any questions, please talk to me. There are no questions yet, so we're already in a good place. Okay, this is the points breakdown for this class. 20% of your grade will come from quizzes, 25% from design assignments, 20% from reading assignments, and 35% from projects, and that will be cumulative. That's going to include your final project as well as all of the other project assignments leading up to it. I believe that the project document itself will only be half of the project grade. The other half will come from the individual projects, making sure that you're handing them in on time, that sort of thing. So here's a course calendar. A lot of this class is just going to follow the progression of the book, which apparently I didn't give you the link to this book in this syllabus, so I will need to update that and upload it as soon as I can. The idea behind this, though, is that we're going to be talking a lot about microprocessors, microcontrollers, integrated chips, how to do design, and different types of design circuits. So it's not going to be, I don't see this as an extraordinarily challenging class academically. There is a lot of very heavy language and a lot of terminology that you're probably going to need to get familiar with. And if you are not familiar with those terms, you may want to spend some time using some flashcards and memorizing those. The big challenge for this class is going to be constructing the circuits. I don't feel like you can pass this class without knowing how to build an electrical circuit. That seems like that would be the worst thing in the world. You need to know how to build stuff, and you need to know how they work. If I do a good job of teaching this class, you will know how to disassemble electrical circuits, look at all the components, see the flow of power through it, and you'll be able to understand how to fix it, where components fail, that sort of thing. That's my goal. Sometimes that can be a lot harder than just buying something new or building something brand new, but I want to teach you how to do that too. So, okay, if you have any questions about this class, feel free to email me at any time. All of you know my email address, but if you don't, that's not my name. And don't email him, because that's not me. Unless I'm also secretly a student in the chemistry program, which I guess could be existent. Yeah. All right, let's talk about your project. So, with the spirit of this class is intended to help you understand not just how to construct, but how to analyze, assess, evaluate, and improve electrical circuits. I think a topic that falls very strongly into this class is IoT devices. Now, what is an IoT device? Yes. That's a project. For this project, we're going to be understanding, you're going to be doing some research, you're going to be doing a lot of research, you're going to be putting together papers, you're going to be performing a design process to create your own IoT device. My goal is that we're going to eventually build these. I believe we have a small enough class that building something like this wouldn't be a major challenge, but you never know in a world like this. We could have our semester end. So I'm not going to promise that we're going to build things, but I have every intention of getting started on building devices beginning basically at the second half of this semester. So we'll see how things go from here to then. But we will be building IoT devices. And maybe that's something that really excites you. Maybe that's something that you have no idea what that is. So I guess I should probably also give you a brief interview about IoT. One of the reasons why Doan's engineering program emphasizes electrical engineering so much and a lot of electrical circuits is because everything is getting more intelligent. AI systems are becoming stronger. You have crazy algorithms that are being put out. People are touting, thinks like a human, thinks like a human. They don't, but this is the direction that design has gone. We're trying to automate a lot of systems so that we can reduce inefficiencies, so that we can improve safety, reduce the workload required for humans, and increase the quality of life. That's a lot of what electrical engineering is intended to do right now in industry. Now, IoT devices are part of that. IoT devices are being heavily used. Internet of Things is what IoT stands for. And IoT devices are electrical devices that connect directly to the internet, usually using a cellular or a Wi-Fi device. And it connects to the internet. Oftentimes it will store data in some sort of cloud. That data can be processed, analyzed, and sent to an end effector to really handle something. For example, a lot of heating systems, imagine Doan's campus. Doan's campus is spread over here, Lincoln, Omaha. They shut down the Grand Island campus, so that's it. With these three campuses, if you have a single facilities team and you have a malfunction in a heater in a building in Lincoln, it's going to be 30 minutes before somebody from Crete can drive out there at least. No, it's going to be like 40, 45 minutes. But it's going to be a lot of time between being here and being there to fix it. In an IoT system, what a lot of IoT systems do is they give advance notice. IoT systems usually involve sensors. And they're sensors that provide information. Sensors can be anything from a camera to a thermocouple that measures heat to just a variety of different devices that are able to send information. So with an IoT device, it's just a very simple device. Oftentimes they're extraordinarily low power consumption. And they send data regularly over a fixed connection to a cloud or to a server where that information is processed and that information is used to make a decision. So if something went down in Lincoln, an IoT device would either A, give advance notice to individuals here that something is wrong with the system, B, would actually be able to implement a fix to the system itself, would probably be a temporary fix, or C, would actually be able to adjust the system settings to overcome the problem, which I mean, all three of those are possible. One of them is heavily manual as a solution. One of them is partially manual because you go in whenever you feel like it and fix the problem. And the last one is it's a self-fixing problem. So, excuse me, I haven't talked this much in a long time. Yeah, so that's going to be our project. For your first assignment for the project, which is going to be due next week, you will be looking up what is IoT. You're going to take a little bit of this discussion that I gave you today. You're going to go do your own research. Now, I will say this. Your research on IoT devices, I will be grading it heavily based on whether or not you can tell me how much you understand the industry. If you come back and say, IoT is only used for heating devices, I will know you didn't do any research. Okay? How about you watch a video? So that's a great way of showing yourself as a novice. Don't do that. Do your actual research. Have some curiosity, okay? Because at the end of the day, I want to give you your own free ability to design your own IoT system, IoT sensor, I should say. And that's going to depend heavily on what you want to sense. If you want to be an IoT camera system, if you want it to be an IoT heat sensor, IoT leak detection system, there are a number of IoT systems. Quite frankly, every cell service, every internet communicator service has their own IoT system that is proprietary and works with their devices. Everyone does. And the reason for that is because right now they can't communicate with each other. And there's a huge market for IoT developers. Because an IoT developer, if you go work with a company like Verizon, you go work with a company like AT&T, as these companies grow and succeed and are able to implement those solutions, they refer back to the devices, the IoT devices that are inside of their own system. And they could be using a design that, if you created one of these IoT devices and submitted it to them, they could be creating a design or implementing a design that you created yourself. I had a conversation with a Verizon representative last year who told me about the Verizon IoT development kit and all of their interesting things that they can do to help people design IoT devices and get them to market. That's a lot of what motivated me to implement this project. Now, I don't know if we're going to get that rigorous. This is the first time I've done something like this. So I cannot promise you that I know perfectly what's going to happen, or even what all the steps are taking to get there. I don't have a lot of experience in this area, but we will do our best. It should be interesting, and we'll all learn something, dang it. All right, if you have questions, email me. Otherwise, I will see you at 10 a.m. I will not see you. I will see a camera at 10 a.m. on Wednesday. And that camera will stare at me just as blankly as most of my students in my classes. I'll see you later.